Hello engineers, ladies and gentlemen. Welcome to another exciting tutorial. My name is Dele from DevOps and Cuts. Today, I'll be showing you an end-to-end implementation of how to deploy a Python Flask application in the cloud on an EC2 instance. But to make this even more interesting, we shall be deploying our application as a container. So we shall build a Docker image and run our application as a container on our machine. And to make this even more interesting, we should do this using infrastructure as code. We shall use Terraform to achieve this. So we shall use Terraform to provision our infrastructure. That will be our VPC, the internet gateways, the subnets, everything else, networking with Terraform. We should also create our virtual machine and bootstrap it with all the dependencies that we need. And then we shall clone our application files from a public repo, GitHub. And then we shall build our Docker image. And after that, we should run our application as a container. Interesting. So sit back and I'll see you at the terminal. So what's our plan today? We shall use Terraform to provision an AWS infrastructure and deploy a Python application as a container. And we shall do this using Terraform infrastructure as code. So we shall write the Terraform files, create the networking, the whole infrastructure, the compute EC2. Then we shall use a user data script in our EC2 to automatically install Python, pip, psutils, git, and Docker, which we need. This will be done during the creation of the instance automatically. Then we shall clone our Flask Python application from a GitHub public repo into a folder in our EC2 instance, also automatically. And then this script will also build a Docker image from our application and then also run our application as a container. After that, we shall view our application in our web browser using the public IP address of our instance with the port for the app, which is going to be, by default, is port 5000. Yeah. So there's the plan. We have our Python code and Docker file in GitHub, and then we use Terraform to create the whole infrastructure and deploy. So let's go to the repo and see our Flask application written in Python. So we'll go to my GitHub repo, and there you can see the files are made up of 3. We have the template folder, then we have my app.py, that's the entry point to the app. Those are the files. So we need to import psutil, and then we need psutil and Flask to run this application. Then requirement.txt, there we have Flask and psutil. So these are our dependencies. And there in the templates we have our index file, which we shall use to display our application in a browser. So those 3 files make up our Python and the Flask application. And that's a Docker file, which we shall use to build an image from the application, and consequently our container, run as a container. So that's what we need. So now let's go and look at our AWS console. We shall be using Terraform to create infrastructure. We'll need an EC2 to do this. So let's go into the instance. Let's see what we have running. No instance is found. Yeah, so we have built nothing yet. By the time we run our Terraform and everything else, that should be able to that will build our infrastructure. So it's about time. Let's begin. So let's first of all do our provider.tf, which we shall use to declare a provider. We're using AWS, so we need to declare a Terraform block and the provider block. Yes. So let's start with this. Provider.tf Terraform block. It shows that we have a required provider, which is AWS. The source will be HashiCorp, AWS, and we're going with version 5.0. As for okay, and then the provider block now. Provider will be AWS. We're going to build in region US East 1. You can choose your own region, probably the nearest to you. Next, we shall do a networking, which will include our VPC, our subnet, which I'm using one subnet, the public one, just for simplicity in this tutorial. And then we shall do our internet gateway, the routes to make up our networking. So let's do the for the VPC. Let's use a pattern name rather than main. Okay, so we can recognize it in the console if we have to, in case we have a lot of VPCs created. So we're going to call it Python app VPC. Okay, and let's just save this. It's nice to save as often as possible. When anything goes wrong, you don't lose to any information or any of the work you have done. Okay, that's our subnet, which we've called public, main public subnet. And you can see that it's assigned to that VPC, so it's a subnet in our VPC. You can see this is AWS VPC.main.id. VPC is called main, so it's in that VPC. Now, an internet gateway, because we need to give internet access, we need to make it public. So we need an internet gateway to do that. We've called it main internet gateway, main IGW. Also, you can see it's assigned to the VPC ID, which is our same main VPC main. So the internet gateway is going to be inside the same VPC, and we shall use it. And the subnet will be using the internet gateway to make itself public. So now we need to get route tables for the internet gateway, so it knows how to route traffic. And after that, we shall do we need to get routes in the route table. So routes should have a destination and a source. The destination means we've used 0.0.0.0/0 means everywhere, the internet everywhere, and then the source, that's going to be a gateway ID. That's our internet gateway. So we shall use the internet gateway to reach the internet, and then we have to associate this internet gateway with our subnets. So there, we've done an AWS route table association, and there you can see subnet ID as well as route table ID. So now we know this subnet will use this route table, which would reach the internet. So that's all we have for the networking part of our code configuration. Next, we shall go for the security groups, which is the firewall. By default, nothing is allowed to get into our instance, so we have to create inbound or outbound rules to control traffic. So touch security.tf, that will create a new file. Okay, so a file. Now we get to security group. That's the security group. We've called it my instance SG, my security group. And yeah, okay. So now we shall create rules and assign the rules to AWS security group.myinstancesg.id. So we need to create some rules. We need rules 80, internet access. We need rules 22, SSH, and log into the instance. We need root 9000. That's because we need them to use root 5000 for Flask and Python, and then we shall, for patches, we need to do 0 with a -1 protocol to allow downloads and into our instance. So that's ingress 80 that will open up for web traffic. And you can see that the security ID is the security group. So we've associated the rule with our security group with that line of code. This line of code, you see it says my instance IG is the security group we are assigning. And that's the value of security group ID for that rule. So we know what security group the rule belongs to. So that's port 80 open. Now port 22 SSH. This will help us to, if we want to SSH, like log into the instance to do anything, to go into it, we need this port 22 open. So you can see it says SSH inbound. We've also linked the security group with, with this we've linked this rule with the group as well by the last line, the security group ID. The value is the security group we created earlier. So you have to link the rules to the group itself. Okay. Now the last one is for the Python Flask app. We need to open port 5000, which we've already exposed even in our Docker file. So port 5000, as you can see, another one is ingress, Flask inbound. We've also linked it to the security group. So at the bottom, security group is equal to security group ID. We've linked it to our security group. So the rule has been linked to the group. We've opened port 5000, which is the default port for Flask Python. Okay, and lastly, is for our downloads on Apaches. We have egress. This time means we're allowing to go out so we can download what we need or install into our instance. Also link the rule to the group at the bottom. Now we need to get ready to create our virtual machine, or EC2. So that's the file. I'll post the code I've already written for our instance. In this code, we are using an AMI. We're using a AWS data source. You can see there. So it goes in there, and based on the filters, it will retrieve the most recent there, the most recent AMI that conforms, that corresponds to these values, to the filters we've set. So has the kind of name, that kind of virtualization type, HVM, and also the owner has to be Amazon. That's the Amazon number there, account number. So it will go for an Amazon account, and there is the key pair. We're using a key pair that already exists. I already have the private key on my computer, so we use that data source also to get the key pair to set it. Okay, yes, and then here's our instance code. So the AMI, you can see it says data.aws.ami.open.id. The AMI gets the value from the data source we used above. Instance type T2 medium. Yes, can you see that's the AMI above? So it grabs the results from there, gets the most recent one, true, and then it assigns it to our AMI instance type T2 medium. VPC security ID, we use the security ID we have already created, security group, remember, and the key name there is the result of the data source we also put there, the key name. Now this is the best part. After this, where we have, okay, so that's the key pair where it was set the data source. Now user data. This script is what does the bulk of the work below the user data. Yeah, that's the user data. It's going to do all the updates, the installations, building and deployment. So first of all we have to update our package. Then we'll install Docker. There, the script installs Docker, and then installs Python and pip we need, with the -y flag, which means just so it doesn't stop. Now it installs pip3 and installs psutil and installs flask, which we need, sorry. And there installs git, because we're going to use git to clone. Now we'll need two directories, so it's made two directories there. One is app, one app2. We shall use one to download, to clone, and the other we shall extract the files we need. So now we change directory here to the first directory, and then we clone our Python code from Git, and then we copy its contents into the second folder which we created, and then we change directory to the second folder. So that contains only the contents now. And then we shall use a Docker file and build our application, build the image, Docker image, and then we shall now run the image. I can see port 5000. We shall now run the image we created and the file. So this script does all the work for us automatically. So it does this during creation of our virtual machine instance with Terraform. So Terraform does all this. It's amazing. So we call infrastructure as code. It's going to build this. So next, let's do an output. Now, to avoid going into the console all the time, we shall also use code to grab the public IP of our instance that will be created in the future. Because we need to use the instance public IP and port 5000 to access our application on the web. So now we've created an output, and the value you can see is the AWS instance website. That's the name of our instance and the instance public IP. So at runtime, it will extract this value when it's been created, and it will output this on our local machine. So then I can grab this and use that to access our application on the web. This normally can be grabbed from the console after creation, but I decided to do this just to show you that Terraform can still grab this for you. So now let's initialize our code. When we by using Terraform init, this will create, install into the backend, which will have our TF state, keep state for us, and also to download all the plugins we need, the AWS provider plugins, everything we need to connect to the AWS API, and carry out actions on the AWS cloud. So there it is. Terraform has been successfully initialized. So now we have downloaded what we need to download to get Terraform working with AWS, with our AWS account. Okay, let's clear this so we can see what's going on. Now, Terraform validate. This is optional, but I like to do this so that I can make sure that my code hasn't got any syntax problems, or it's not, or maybe it's out of alignment, or I've got an extra character that should not be there. It just checks for minor, problems with your code. So it says success. It is valid. So that's fine. So that is valid. So next we shall do a dry run, Terraform plan. Plan will not build anything, but it will just show us what's going to be built, and if there's any problem, it will also come up. So Terraform plan, we run that. It's beginning to plan. So it will tell you exactly how many, resources will be built, and also, it give us some information before we actually execute the build itself. So you can see here it says it plans to build 12 resources, 0 to change, 0 to destroy. So it's going to build 12. Now, can you see? Okay, hold on. Yes, it's telling you what we will create. It's going to create that's the instance. It will build an instance. You can see that's the internet gateway will be built. Now you can see it's talking about it's going to build a route table. It's going to build a route table association. Going to build the security group. Create that for the instance. Next, the download rule. That's the download rule for the instance. Now that's the flask rule, 5000. Now that's the but 80 HTTP rule for the security group as well as there. Now that's the subnet, public subnet as well we're building, and that's the VPC. So plan 12 to add. So that's going to build 12 resources. There you can see 12 resources to add.
So next, let's now go and begin to actually create the resources. So we need to run Terraform apply. I would use the auto approve flag so that it doesn't stop to give us a prompt to select yes or no. So it will just execute straight away. The Terraform apply auto approve, and that will begin to create infrastructure in the AWS cloud. So it's going to do a lot. It's going to build a whole infrastructure. It's going to clone our application. It's going to build the application. It's going to deploy. It's going to build an Docker image. It's also going to run a container, and that's a lot of things. We're doing with Terraform. Okay, now it's beginning to create. It's beginning to create. Such a beautiful site. It's beginning to create. It's going through the files, and it's beginning to action every instruction. So you can see it's creating the security group, the group rules, the route table. You can see it's creating all that. It's creating the instance itself, AWS instance. You can see it's creating now apply complete resources 12. Now you can see the application, the public IP which we use for an output has now been removed, has now been created. So we can copy this public IP and use it to access our application container on their browser. So let's copy this. We shall append port 5000 and view our application in the web browser. That's application. So let's hold on. Yeah, okay. So now, first of all, let's check the instances. It should be running now. We should see our instance running in the console. Terraform has built it. There you see my Python app. There it's running. You can see all checks passed. Yep, it is running. So let's go to the browser using our public IP, which we have already copied. Public IP. That's it there. It was the same as the output. So let's paste it here and access it with using port 5000. So let's go port 5000. Port 5000. And it's loading. It's loading. It's loaded. Oh yes, and there it is. So application which monitors the CPU usage of our instance. So that you can see we have successfully deployed a Flask Python application as a container.
So that's it for today. You have learned how to deploy a Python Flask application as a Docker container on an EC2 instance, and you also learned to do this through infrastructure as code using Terraform. So please don't forget to subscribe, like, and share. And I will see you again very soon with another interesting tutorial. Delay, DevOps, and cards. Thank you.